All right, the first thing we're going to talk about today are some more proportions. Remember, we talked about on Friday how to solve proportions using cross products. We're going to do the same thing today. So in that first section where it says solve each proportion, I have 3 examples for you. The first one looks like this. B minus 8 over 5 equals B plus 3 over 4. Now, just like we did on Friday, we're going to use cross products to solve this. So remember, whenever we do cross products, we multiply up and across. Except this time, notice I have to take 4 times b minus 8. So in order to show this, we're going to take 4 times the quantity b minus 8. And you have to be really careful and make sure you multiply 4 times the b and the 8, so using the distributive property. And then the same thing's going to happen on my other diagonal. We have to take 5 times b plus 3. And now once we get to this point, we're going to go ahead and distribute the 4, get 4b minus 32. We're going to distribute the 5 and get 5b plus 15. And we can go ahead and solve this as a normal equation. So notice first I have b's on both sides of my equation. So if I subtract 4b from both sides, we should get negative 32 equals b plus 15. Subtract 15 from both sides, and we should end up with negative 47 equals b. So that's kind of the gist of the proportions that we're doing today. Let's try another one just like that. This one, let's say I have n over 5 equals 2n plus 4 over 6. Okay, so same thing here. We're going to multiply up and across. Remember, it doesn't matter which order you go in. If I go up and across this left way first, we're going to have 6 times n, which is just 6n. And then up and across the other way, we're going to take 5 times the quantity, 2n plus 4. And remember, you have to have those parentheses. It's not the same thing if you don't. So I should end up with 6n equals, if we distribute the 5 to both of those, we should have 10n plus 20. Okay, now notice we have n's on both sides of the equal sign. So if I subtract 10n from both sides, we have negative 4n equals 20. Divide both sides by negative 4. Should end up with n equals negative 5. Okay, and last one of these, and then we'll move on to a new topic. This one, let's try x minus 2 over 3 equals x plus 3 over 5. Okay, so same thing, multiply up and across. We're going to take 5 times the quantity x minus 2. That equals the other one, which is 3 times the quantity x plus 3. And just like the last ones, distribute the 5 to both places. We get 5x minus 10. Distribute the 3, we get 3x plus 9. And then we want to go ahead, get our x's in the same place. So we're going to subtract 3x from both sides, and I get 2x minus 10 equals 9. Add 10 to both sides. We have 2x equals 19. Divide both sides by 2. We get x equals, you could leave it as 19 over 2. If you wanted to change it to a mixed number, it should be 9.5. If you wanted to change it to a decimal, it would be 9.5. All of those are equal and equivalent. Any of them should work. Okay, now on to the new stuff for today. So the second topic we're going to talk about is about similar figures. Now, similar figures, as it says on your notes, so you can kind of follow along, it's going to be at the very top. Similar figures have the same shape, but they're not necessarily the same size. So notice the 2 triangles that you have pictured on your notes, these would be considered similar figures. Now, similar figures have some important things in common that we can use to our advantage. The first thing is it says the measures of the corresponding angles are equal. Okay, so let's go over here to this little piece of information you see here. Okay, so this is how you would read it. It says triangle ABC, and then this little squiggly line here means is similar to triangle DEF. So it's telling me that this triangle and this triangle are similar figures. So the 3 things that we know about similar figures is the corresponding angles are equal, the corresponding side lengths are proportional, and the order of the letters is very important. So the first thing we're going to talk about is this very last note here. where it says the order of the letters is very important. So when it says triangle ABC is similar to triangle DEF, it's actually telling me which angles are corresponding. And it's important to know which angles are corresponding because, like I said, they're equal. So if I say triangle ABC, since A is the first letter in the name, over here, angle A should measure the same as angle D. And if you notice here on my picture, see how A is marked with one arc and angle D is marked with one arc? So my picture also shows me that these are congruent. If you notice, B is the second letter and so is E. It means that B and E are equal. And then same thing with C and F. Since they're both last in my name, C and F are congruent as well. So the way we could show this over here where it says corresponding angles, and I want you guys to write this in your notes. If I wanted to show that angle A and angle D are the same, we would say angle A, and then you're going to do an equal sign with a little squiggly line over it. This means congruent, which for all intents and purposes of this lesson means they're equal, means they measure the same. Okay, so angle A is congruent to angle D. We can see that from the name, the information they give me, and I can also see it in my picture. Okay, another set of corresponding angles we said would be angle B, which is going to be congruent to angle E. And then finally, angle C is congruent to angle F. Once again, you can see all of this in the information they give me just right here. And also you can see it in the picture by them marking it with those arcs. Okay, so that's really useful. That's really important. But what is even tends to be even more useful is this second part here where it says corresponding side lengths are proportional. So the corresponding side lengths are the side lengths that kind of match from one triangle to the next. So for example, if I look at my picture, they're kind of aligned the same way. So I can see that this side length and this side length, those are what we call corresponding side lengths. Now you can see it in the picture, but once again, also in the information you're given, you can tell as well. Since AB are the first two letters, side AB is going to correspond to side DE. Okay, so what I can do is I can set up a ratio of these two sides. So I could put side length AB over side length DE. Okay, and that's going to set up a ratio. So what I know and what I'm going to find out is that that ratio, AB to DE, is going to be the same as the other corresponding side. So if you look at your picture, you notice this side on the right, BC, and then this side on the right, EF, and you can tell also in the name, since they're the last two letters, this ratio is going to be equal to the other one. So I'm going to say BC over EF. Okay, they are proportional. And then I could even tack on the third set of sides. So this bottom one here, this AC and this DF. So I've got AC and DF. All three of these ratios are equivalent. Okay, so let's go on to this next little. So it gives me a picture and it says the figures in each pair are similar. Identify the corresponding sides and angles. And we're given the information that triangle ABC is similar to triangle XYZ. Now they give me a picture, but I don't actually need a picture. I can just look at the name, but sometimes it's kind of nice to see the picture. So first, let's start with our corresponding angles, because these are really easy to do. Like I said, you can just look at the name. So since the A comes first, its corresponding angle is going to be the first letter in the second one. So I could say angle A, once again we say, is congruent to angle X. All right, if we do the same thing, the second letter in those would be angle B is congruent to angle Y, and angle C is congruent to angle Z. If we wanted to mark our triangles, we could using arcs. So I could say angle A is congruent to angle X. Now I could use two arcs to show angle B is congruent to angle Y, and I could use three arcs to show angle C is congruent to angle Z. So the angles are important, they're useful, but the sides are going to be the same. So I actually think when the triangles aren't aligned the same way, it's probably easier to look at the names. So if we start with the first two letters, that would be AB, and then if I look at the first two letters in my second triangle, it's going to be XY. So there's one of them. Okay, that's going to be equal to, let's do BC. So the second two letters, okay, in my first triangle are going to be corresponding sides with the second two letters in my second triangle, which is going to be YZ. And then finally, we can do the first and the last letters, which are AC and XZ. Okay, and so what we find out, and let's actually step this out, is that if I write these side lengths, so if you consult your picture, so AB is 4, XY is 5, and then if I just kind of fill in the blanks here, BC is 6, and YZ says it's 7.5, and then if I do AC, which is 8, and then it says XZ is 10. Now what we're going to find out is that all of these are equal. Now this middle one's kind of throwing me off because if you turn it to a decimal, you would see that it's the same. But notice, if you reduce 8 over 10, it's going to give you 4 over 5. If you turn all of these into decimals, you should notice you're going to get 8/10. They are all the same. That's the cool thing about triangles. It's going to be really useful for us. So how we're going to use this information is we are going to find some missing side lengths. So they give me the information that the figures in each pair are similar, so we're going to find the missing side lengths. And we're going to do this by setting up a proportion because we know that the side lengths are proportional. So they don't really give me the information that this triangle is similar to this triangle, so we're just going to have to kind of pair up the sides as we go. So what I'm looking to do is I'm trying to set up a proportion. So remember, a proportion means that two fractions are equal. So this left-hand side of the proportion here, this ratio is going to have to be one side length from this triangle over its corresponding side length from this triangle. Well, that's pretty easy to see. If I look at 12, it corresponds to 6. So in my proportion, I'm going to say 12 over 6. That's going to be equal to, well, then I need to pick a different set of sides. Well, I've got 5 and I've got X. Notice they're both on the bottom. So then we're going to write 5 over X. Now the really important thing you have to remember is that if I'm going to use 12 first, meaning it's going to go in the numerator, I have to stay consistent. So I'm going to do big triangle over little triangle, big triangle over little triangle. You can flip them around. It'll give you the exact same answer as long as you stay consistent. So now we have a proportion. We know how to solve this. We're going to multiply up and across, and I get 12x equals 6 times 5 gives me 30, and divide both sides by 12. And if we write that in simplest form, it's going to give me, I believe, about 2.5. Okay, so we're going to set up a proportion and we're going to solve. Okay, so let's try this other one over here. Once again, I need to set up a proportion. Okay, now on my ratios, I need one side length from each figure. So if I pick, maybe this time we do 6 inches and think about which side over here corresponds to it, well, we can see it's going to be 6 and 15. So in my proportion, we're going to write 6 over 15. And then the other half of my proportion, since I went small to big, I have to go small to big. So we're going to write 2 over x. And then just like in the other one, we can go ahead and use our cross products to solve. So I have 6x equals, and 15 times 2 gives me 30. Divide both sides by 6, and we should get x equals 5.